Oh, welcome back, everyone. I seem to have decided to do this one more time. I'm not that I'm beer motivated or anything, but it is a good excuse to have a drink. Uh, Today's beer, Rochefort Trappist. They're number 6 because I would actually like to get round to writing a test. I have an epically long to-do list, and it would be wonderful to, see it shrink slightly. So, for those of you asking what today's beer is, today is another Trappist beer. It's the Rochefort. I'm usually a bigger fan of the blondes, but number 6 will have to do today. Cheers. Mm. Oh yeah, that will work. I have something very special in mind for next week. That we'll all enjoy very much. No, wait, I misspoke. That I will enjoy very much. But we'll keep that a secret for next week, and I'll also explain what I'm celebrating next week. Next week. In the meantime, we should get started trying to do something productive, and if I can actually show it on the screen. This is something I did earlier this week on Wednesday, apparently. Syscaller, for whatever reason, has decided to start actually testing PF, and it started finding some amusing bugs. Well, not terribly amusing. This one is just a lack of input validation on ioctl, and it triggers a panic happily only in an assertion in the PF. Yeah, this was an assertion in the PF code. It asserts, but actually it doesn't matter. If you ignore the assertion, say that you've built without invariance, which is a release builds, which most people run, it won't actually break. So it's not a security issue. It's not a major problem. It's just a problem. So we might as well fix it. Ed has very generously reviewed this for us. He had one remark about having the kernel set it to null versus requiring that it's null. So actually what we should, well, we can get some more code out here. Right, so we're in the ioctl handler. Ioctl handlers very typically large switch case statements. It's too early to start tripping over my words. I'm not that drunk yet. But anyway, they take from other here, they take a pointer to some memory that got copied in from user space. So everything provided there is by very untrustworthy user space. And then we go look at, does the address family make sense? Does this make sense? Does that make sense? Is the type valid? If not, we return an error. And this is what I've added: is this variable set to null? If it's not set to null, we consider this invalid. We return. We don't actually do the operation that that the user requested. So the distinction here is we could set this to null for the user and just continue. Or we could say, no, user, you fed us garbage information, we're not doing the request. Argument that I'm making why we should do it this way rather than setting it to null is admittedly slightly far-fetched because we're not likely to do this, but is basically if ever we want to extend this particular call, which is add addresses, and we want to pass a value in this pointer, which actually let's go to the code because everything starts and ends with the code. That'll be easier. So we want to be in this file. This file, dir add adder. There we go. You may recognize this. If we go look at pp adder.adder, what is, well, is a pfioc pool adder. which contains a PF pool address, which contains an address wrap, which there we go, from which we use p dot, which can be a number of different things. So it could arguably be that there could be, we could add something to the union, which we're allowed to do because that doesn't break binary compatibility. We could add something there. We could conceivably start to pass valid values in that. If we do that, how will we distinguish a user space that passes as garbage from a user space that passes as valid information? You can imagine user space passing as garbage by not actually initializing this field, by not zeroing out the structure before it gets passed to us, and then we just get random stack garbage, and we wouldn't be able to distinguish it from a value that we might potentially be interested in. So it's generally good practice in ioctl handlers to, if you have a spare field, actually check that it's set to the empty value. It encourages user space to do the right thing, which is to initialize this to null, so that if ever we update the kernel and say, hey, we want to get some more out of this, we haven't made our own life more difficult than it needs to be. Long story short, we've fixed this particular problem. We are now going to just do a really quick commit. Batch-i tmp batch svn. Commit this. This was found by syscaller. Syscaller is, for those of you who don't know what it is, it's a Google tool. They run, well, it's an open source tool from Google. Reviewed by eMass. And we want to MFC this in a week. And before I forget, there's a differential revision for this, so we want to include the link. Right, I was talking about syscaller. Syscaller is a profiling-driven fuzzer. What it does is it's a fuzzer, so it just throws random garbage at the input of ioctls, system calls, all sorts of things. It throws random garbage at them, and it does this until something panics. Now, panics are not supposed to be a result of an ioctl, so then we know that we've discovered a bug. The problem with throwing random inputs at something is that there are a lot of variations in random inputs. The clever bit in syscaller is that it uses profiling information, so it looks at which branches, which bits of the code have we run data through. And then based on that, we know or we don't know that, or based on that rather, we can guide the random inputs and see if it works better or not. Or see, we've taken this path or we've not taken this path, and based on that, it guides itself through trying to cover as much of the code as possible, because hopefully one of those paths will do something invalid. Well, hopefully it won't, but it's a debugging tool. It tries to find bugs, and it is happy if it turns up. Yeah. Yes, if you're getting video stalls, that might be my fault. I don't actually know if there's something I'm doing wrong. Excuse me a moment while I go off screen and take a quick stab and see if there's something, or if there's a particular reason why my internet connection would decide to be slow today. And at first glance, no, there's no obvious reason. So for now, I'm just going to hope that this goes away. If it doesn't, I will see if I can reduce resolution or something. So do keep shouting at me if it breaks. The good news is that at least the stream dump that will end up on the internet eventually should at least not have these issues. So here's hoping that this gets better, so we can commit this fix. There we go, that's one. Next thing I wanted to get up to today is I promised someone I'd write a test. Actually, I promised Mark that I'd write a test for the... Was it Mark or did I promise someone? Anyway, I promised someone that I would write a test for the MAC address changes that we looked at last week. I had arguments all week during the review, but it got committed, and I did promise to write a quick test for that. So today we're going to write a test. Sysnet, because we already have bridge tests. Oh, and what we should do while we're here is we should reverse dispatch. So this one. So this is what we wound up doing. We wound up killing a whole lot of code out of the bridge. All of the bits in red is this is code that's gone. And it's all been replaced with this, which works better and is much simpler. So, that's a win. But I want to revert this, because I want to break my kernel again, so that when I run my test script, it will confirm that the bug is actually still present. So what we're going to do, we've done a git show patch-r p1, there we go. And we can build this kernel while we start looking at another bridge test. So weirdly we start. I start writing this test from the bottom. ATF calls ATF init test cases to be told what test cases there are. So we've added the test case to the list. So ATF test case. Now we're going to define the test case. Mac conflict and cleanup. Cleanup just tells ATF the automated testing framework, which we liberated from NetBSD. It just tells it that there is a cleanup function because we're going to be spinning up jails and creating interfaces, and they need to be destroyed before we start the next test run. So mac conflict heads. There's a description, ATF set require user root, because you really do need to be root to run this test. Mac conflict body, which is where we will actually implement the test, but we'll just really quickly write the cleanup function, because that's all it takes. So VNET init, what this VNET init function does is very little. Mostly it just checks that we've got VNET support in our kernel, because otherwise we can't run these tests and we just skip them instead. When you go look at a large test run, there's always a bunch of tests that get skipped because required modules are not loaded, because required tools are not installed, because required kernel configuration is not done. That's mostly normal. Just do pay attention that when you're touching a feature that relies on, and you want to test it, that you don't get too many skipped tests. So we want to, we're going to create our bridges in the jails, because yes, that is most likely to result in conflicted in MAC address conflicts. Remember, oh, there we go. We can go and install that kernel somewhere. Well, not somewhere, where it needs to be installed. And what do we want to do? We want to create two jails. So VNET and K jail 1, and we're not actually going to give it any interfaces right now. Oh, and we're going to use a fairly long name for it, because this means that we're not going to get name conflicts if we start running multiple tests at the same time. Not sure we're ever going to get to a point where all of our vimage jails are sufficiently, or vimage-based tests are sufficiently deconflicted in jail names, in not using the host system routing table or interfaces in the host system or anything. I'm not sure we're ever going to get to that point, but, well, we might as well not make the problem any worse than it is already. So, two jails. What we do want is, yes. And we want an e-pair because we're going to link them, but we're going to stick a bridge in between them. So the test plan here is we're going to create two jails. We're going to create bridges in both of those jails, and then we're going to link those two bridges together with an e-pair, just so that the two jails can notionally communicate. And then we're going to ask them to ping each other. And if that works, we can safely assume that they do not have a MAC address conflict, because if they do, it's not going to work. Which we'll confirm afterwards with this test that should be broken. So, next step is jexec bridge MAC conflict 1 ifconfig bridge create. And we're going to be kind of naughty here. We're going to make potentially unwarranted assumptions. What we're going to do next is ifconfig. We're going to assume that it's called bridge 0, which will be true because it's new jail and it doesn't have any bridges in it, but ideally we should take the output of this command and yada yada yada, but I'm lazy and all of that. 2.0.2.1/24 and up, and e-pair add the member. This should work in one go, hopefully. So, except this is jail 2, you do need a different IP address and you need e-pair B. Okay, one more thing that we need to remember to do. Conflict 1 ifconfig. We do need to remember to set our member variable up, our member interface rather up, because otherwise this is still not going to work. Okay, so we have those up, and now we can run the actual check, where we expect an exit status of 0 when we this is not the, there we go. We want to ignore output because ping produces a lot of output that we don't care about. Bridge MAC conflict 1. In that jail, we wish to perform a ping with, say, 3 packets to 192.0.2.2. And that really should be it. So we can and install this test, and now we can go tests sysnet, and we should have a bridge Mac conflict test. Awesome. QA debug this particular test, and I say debug because then I get some output. So question from chat here is, does QA ATF take care of allowing raw sockets, which you need for pings, or is that not needed with VNET interfaces? And the answer is that you don't need to do that with VNET interfaces. You have your own IP stack. You don't need to give that jail permission to do things like raw sockets, because the risk is gone, because you can only do it on your own interface. You can TCP dump on your own interfaces. You can use raw sockets on them. You can even set firewall rules, because it's your network stack, your IP address. You get to do whatever the hell you like with it. And if you break it, you get to keep the pieces. So clearly this didn't work very well. Oh, and I know why this failed. This is kind of annoying. The bridge is a module. It's a loadable module, and it gets implicitly loaded the first time you try to create a bridge. Except when you're in jail, because in a jail you don't get to load kernel modules, because otherwise you could escape jail, and you're not allowed to change, not allowed to escape jail for obvious reasons. So the end result, and that is what we ran into here, is that you try to create a bridge. We don't have the bridge module loaded, so it tries to go and load the module, and it can't because it's in a jail. So what we can do is we can KLD load if bridge, and if we run the test now, it will fail differently, or possibly even succeed like it just did, which is pretty awesome. But that doesn't actually fix our test. So we could teach our test that it needs to actually load this module, or check that this module is loaded, or any of another number of things. But we're just going to cheat. And do this. We're just going to create a bridge in the host system that we're not going to use for anything. Make install. Now, of course, our test worked, but we can KLD unload if bridge, which miraculously didn't panic, because I struggled for a while with PF to make it not panic when you unloaded it. So there we go. And if we KLD stat now, we will notice that actually the bridge module got loaded again. So that's awesome. And this means that our test so far has worked. What we could also do while we're debugging, just as a verification, bridge mac conflict 1, ifconfig bridge 0. And we'll do the same thing in 2. So this is strictly for our own education. Just to make sure that when we get the output of this, the test will succeed because we've not changed anything. But what I wanted to see is, oh look, these MAC addresses are different. They are very different. That is excellent. That is what we wanted to see. Okay, and now we're really quickly... Hang on a second. Because I did install and rebuild this kernel. I'm not entirely sure. Well, actually, maybe. Hang on a second, because I can't think and talk at the same time. Yes, because we've still got this one. we need to do this as well. We need to reverse that patch as well to really properly break it again. While we're waiting for that to build, chat had a couple of relevant remarks. So in VNet jails, it's true that you get to change your IP address to whatever you like. That may or may not be something you want. Typically, when you don't want the jail to be able to change its own IP address, you would use old-style jails, and that should work just fine. But you can do VNet. There was a GSOC project last year for apparently called Mac IPACL, which is, I don't recall the name. I know that Bjorn mentored it, and the patch got approved but not actually committed for some reason. Somebody should chase Bjorn and make sure that it actually ends up being committed. What it would do is use the Mac framework to ensure that jails can't actually change their own IP addresses inside VNet jails. There are use cases for this, so it's a cool feature to have. I don't use it because these are tests. We're not interested in that unless we happen to be testing that particular feature, but that's not relevant right now. But it is useful to know that it exists, and sooner or later, hopefully it will get merged and we can all have these nice features. Oh, well, thank you very much. You get to take credit for that module existing. You should feel proud of yourself. Another remark was that should we unload the bridge kernel module? Yeah, maybe. To be truly idempotent, to be truly, you run the test, and once the test is over, there is no evidence that this test has ever run. Arguably, you should unload the module. On the other hand, it doesn't do any harm to be loaded, so we're not going to make the tests any harder than they need to be. Because if we wanted to unload it, we'd have to make the distinction between we loaded the module and it's not obvious because it gets loaded implicitly by ifconfig, because we don't want to unload it if we weren't the ones who loaded it, because we might break a system that way as well. So by and large, we just don't bother. It's fine. The module doesn't do any harm when it's loaded, and also, you really shouldn't be running these tests on a production system. No, really, they panic. Even on release systems, it is not impossible that you're going to run into a panic. This takes a little bit longer, which is a good sign because we want this test to be broken. Excellent, it failed because we reverted our changes that fixed the problem. Oh, right, yes, that does want password, that's okay. And we're going to add this, except definitely not this, also not this, not this either, but we do want to add this, except we don't want to add all of it, we want to delete these bits, because these don't serve a purpose. So we used to have a problem where bridges created in would end up having the what's the word I'm looking for? That it doesn't regress. That's the word I was looking for. Does this need any particular? Nope, this is fine. There we go. I'm going to be extremely lazy, and this one I'm not going to bother to get reviewed. We're just going to commit it and call it good. There. And then we can commit this, git show this. Just paste the commit message in there. I can assure you, chat, I am not reading your mind. The number you are thinking of is 42, but I am not reading your mind. So there we go. There's another test added to the list of tests, because more tests always better. That lets me check off an item from the to-do list. And we're going to check off another one. Oh, don't panic. No, those thoughts are perfectly normal. I can't help myself, sorry. Right, oh, yes. What we were going to do is I have an ancient to-do list item, and I'm actually going to go and have a quick off-screen look if my to-do tool will tell me. Yes, okay. So this is why I describe it as ancient. I added this particular item back in 2015. So when I say that the to-do list is long and deep, I'm not kidding. So this is the entirety of the to-do list item. It's for PF. The PF frag mutex should be VPF frag mutex because it's a per VNET queue. So what have we got in PF? There we go. We've got a mutex, a static mutex. Oh, that gets statically initialized, and it's a PF frag. So presumably, what it does is protect the fragment list. So if we go look at this, it's only used in this one file, which is convenient. We take it when we access the VPF frag queue. And we assert that it is taken when we access this. What this is a queue of fragmented packets. So when PF gets fragmented packets, and it's configured to do this because it's not always configured to do this, it may choose to hold on to these fragments for a little while in hopes that it will get the entire chain of the packet so that it can reassemble the packet, go take a good, long, and hard look at the entire packet before deciding whether it likes it or not. Details of this would lead us far, far too far away. But the important point here, and the thing that we're going to try to improve mildly, because it should be fairly straightforward to do, is we keep them in a queue. This queue is protected within mutex because we can only add or remove items from this queue one at a time. That's all fine and good, but we have a queue per VNet. So if we have 1,000 jails and all 1,000 jails are running PF and all of them get fragmented packets and try to insert things or remove things or look things up in that queue, they will all contend on this one mutex. And that's kind of silly. The obvious thing to do here is we want this mutex to be done. We want this mutex to be per VNet because the structure that it's protecting is per VNet. If you've got jail A and jail B both trying to insert things into their own lists, there is no reason for jail B to wait for jail A. So we can just turn this mutex into a per VNet mutex, and we will remove a source of potential contention. I'm pretty sure this isn't going to result in any sort of dramatic speed up because there are enough other places where we can contend and slow things down before we would run into this, but this one is trivial to fix, so we might as well fix it. While I was explaining that, I got a question from chat. Is packet reassembly in PF and IPFW handled by BPF? Because it doesn't seem to be available anywhere where BPF isn't available. No, fragment reassembly is handled by the firewall in bespoke code for the firewall. So we've got, say, find fragments. So there we go. Fill up fragments, PF reassemble. So this is there we go. So if we normalize IPv4 packets, one of the things that we do for IPv4 packets is we reassemble them. And during reassembly, we will fill up packets. So the entire reassembly code for PF is just hand-rolled, is in PF code, and it does not rely on BPF. I don't know off the top of my head how IPFW handles it. IPFW is done by people who are, much smarter than I am. So, getting back to what we wanted to do, we want to virtualize this variable. And so we've got a static struct mutex pffrag mutex. So instead, what we want is a VNET define static. And then we want the type, which is struct mutex. And then we want the name, which is going to remain pffrag mutex. That's all fine. And then we want to define our accessor, which does that does not take a leading, so that becomes v pffrag mutex vnet frag mutex. There we go. So this definition goes away. And then the only thing that I still need to work out is, can we mutex sys init this? This is a sys init. Do we have a variant for VNET per VNET mutexes? I kind of hope that we do, because if we don't, this is going to become a lot harder than I was hoping it would be. So what does this do? This just statically defines that we've got our static struct, we populate it with all sorts of things, and then on sysinit, we have a mutex sysinit function that we pass these arguments into. So presumably what we're going to want is something extremely similar for... did we? I'm sure we had a VNET header somewhere. So we have a VNET per CPU declare VNET sys inits, a VNET sys uninit. What we probably don't have is a mutex initialization for VNETs. That will be too much to hope for. Of course we don't have that. That would have been too much to hope for. This is mildly annoying. So we get is virtualized sysinits. So we can use a VNET sysinit for this. So we should, if def v image define v mutex sysinit of name mutex desk and opt, and then it's basically the same thing. So what we want this macro to do is work in exactly the same way as mutex sysinit, except we want to initialize per VNET. So we want to VNET sysinit, which becomes name mutex sysinit, blah blah blah. How many arguments does this take? VNET sysinit is essentially the same because it takes an ident, it takes an order, it takes a subsystem order, and then it takes a function and an argument. So with any luck, this will actually just work. Except we do need to break this line earlier because reasons, and then we need to there. So this might actually work. So what we want to do then is pf frag mutex. Where is it? Pf frag mutex again. We want to v mutex sysinit this one. And then when we typing is hard, and then we want to use the per VNET mutex for this. And then the fragment mutex is not actually used anywhere else, so this user source might actually compile. Or it might not. Oh, right, yes, we've touched the mutex header, so we're going to be rebuilding the entire kernel. Oh well. Assuming that this works, I have one question to which I don't really have the answer. Well, actually, thinking about it, yeah, considering that we have sysinits are defined in the kernel and we redefine them in VNET, or we redefine the VNET variants in the VNET header, I think we might want to move this define into vnet.h rather than from the mutex, but we're going to let this compile first. While we're waiting for this to compile, meta mode is, I don't think that I do. What is meta modes, not meta mods? Meta mode, is meta mode a Vim thing or is that an Emacs thing? I don't remember, and I can't actually immediately find it. Okay, yeah. So I think that I do not. Okay. Oh, okay. Oh, okay. I see. Well, what have I done to my browser? Oh, there we go. There's the. Wow, this. Nope, definitely don't want that. Meta mode, this window we want is an incremental build option for FreeBSD which uses bmix, meta mode, and filemon to create meta mode, substantially decreases the time taken to build FreeBSD. I do not. I should look at that because I don't use it. Okay, I am going to have to play with this, but not today, because it requires a full clean build. But someday I'm going to play with this. Thank you for that hint. That may turn out to be useful. My box is by and large fast enough that kernel builds don't take all that long. Yeah, thank you for adding things to my to-do list. I managed to remove one item. If I end up adding 3 more, I'm going to be very upset with you, okay? Hopefully we can knock this one off. This patch, if we turn out to be happy with it, I am going to want to post for review because it affects more than just PF. And it may end up getting split into two different patches, one of which will add the vmutex sysinit, or possibly mutex vnet sysinit. I'm not entirely sure which one makes most sense, but we can argue about that in the review when we get around to doing the review. The thing that I'm most interested in here and now is, does it actually work? Oh, while we're waiting for this to happen, I want to see... So there was a bug very recently in, between Scapy and FreeBSD current that breaks a bunch of tests. Ports. Breaks the tests because Scapy fails to discover the IP address of the interface that you're sending through, and then ends up sending packets with a zero source IP address. And if you're interested, you can go read up on it on the testing mailing list. There's a fair bit of information about what the bug actually is. The port maintainer has fixed this problem, or I believe has fixed this problem. Oh yes, there we go. There we go. Oh wow, look at that. I'm credited in a ports commit. So this is awesome. Oh no, wait, ports revision 3, and I think, yes, we have ports revision 3, so it should be fixed, so that's good. The bad news is that our compile failed along the way. Okay, so our macro doesn't actually work yet. Ah, yes, because this identifier doesn't exist. And because we need to do this, hopefully. I'm not actually fully convinced. No, wait, yes, no, maybe. No, this should work. This should work. VNET can be mind-bending when you get into some edge cases, but by and large, it's not terribly difficult to use. Still don't have it quite right. So something else still fails. Okay. Yeah, that's annoying, isn't it? That is very annoying. Because the initializer element is not a compile time constant, and that's right, because VNET plays some very silly games. This isn't going to work. Sorry. Point is, VNET plays silly games, or plays games with the preprocessor and all sorts of things to turn this variable into essentially multiple different variables depending on what your curve VNET variable is currently set to. Actually, while we're here, we might go and look at this. So remember that the v_pffrag mutex is the VNET of pffrag mutex. And if we go look at the VNET header, it becomes VNET, which is just essentially what it becomes is we take curve VNET, which is a global variable that gets set to whatever our current VNET is when we change the VNET context, or when we change to a new VNET, and then we dereference that variable with a base and a per VNET pointer to get a per VNET pointer to the particular variable that we're interested in. So lots of preprocessor games getting played here, which means that while in the vast majority of cases we can treat v_pffrag mutex as just another variable, it doesn't always work that way. And that does mean that in this particular case, we end up with a sysinit that doesn't quite do what we want it to do. I think that we can't do this, and we're going to have to manually roll our own VNET sys init function to actually initialize this variable. Now, the thing about that is that I would kind of expect that we already have. We don't. I would have expected us to already have a VNET sys init and sys uninit to destroy the mutex again. So we've got, I'm sure, yeah, there we go. We've got some in other bits of PF, but not in these bits. So we're going to copy from here. There we go. So what we're going to do, I've got a normalize init. Oh, hang on, this is even better. We normalize, because normalize init gets called when we attach the VNet, so we don't need to have a separate sys init for this. We can just reuse this one because it already gets called at startup and at shutdown of this particular VNet instance, so that's sufficient. So we can mutex, what is it, mutex init, and I'm sure we'll have a mutex. Do we not have a, there we go. Actually, what I want to do is do exactly the same thing as we would do in mutex sys init. So we mutex init of vpf frag mutex, and we can give it a description, which is that it is the pf fragments mutex, or just pf fragments. We'll just use the same description as we had earlier. And then did we have, oh, and mutex def. So we're just taking the defaults of values for the mutex. And then we've got mutex destroy. And then we only want to do, when we're done here, mutex destroy of vpf frag mutex, and that should that will hopefully be all we need. We don't need this. No, that can just stay there. We don't need that one anymore. And we can try this again. Now, obviously, we'll want to remove the additional defines we created in mutex.h because we're not going to use them. Okay, undeclared identifier underscore pf frag mutex. I think what that means is, yep, we missed a v in here. The compiler is a, as a typo checker. And more typos, because of course there are more typos. What happens here? Too few arguments, so I've managed to forget something. I don't quite understand how you consider this to be smart when all I'm doing is, typos and breakages and doing things wrong. Oh, okay, so mutex init takes a null pointer in the middle there. I'm assuming that will be the same, but let's go look at the man page real quick. Okay, it's the mutex and the type, and that's all. What are you doing then? Okay, so is the man page wrong, or is something else wrong? Oh, okay. Now, we do take 4 arguments, so if someone in the documentation team is watching, the mutex init man page is wrong. Oh, no, it's not. I know what the problem is. We need to be here. In the kernel, mutex init takes 4 arguments, whereas in user space, mutex init only takes 2 arguments. Oh, thank you so much for volunteering to fix this, except, it's not a bug because it was just me missing something. So mutex init, does it have more? There we go. It's not actually a bug, it's just me not realizing that there's a difference between a mutex in the kernel and mutex in user space. Must be initialized to use a mutex. The name option is used to identify and in debugging. Output type option is used by the witness code to classify a mutex when doing checks of lock ordering. If the type is null, a name is used in its place, so we can just have that be null. That's fine, because that's what we already had anyway. So let's try this compile again. So a whole lot of work that doesn't need to be done again, and it looks like it might actually be compiling this time. Thank you for joining us, Renee. I hope you also have a tasty beverage. It is, after all, a Sunday, and we should all be enjoying ourselves. So it looks a lot like this might actually compile, which means that we can run the test through this. And actually, while we're here, we might as well net pfillpf go run these tests to see if they work. The forward test is the one that used to fail, so I'm hoping it will now succeed. Because I think I've got the correct version of the Scapy binary installed now. And so hopefully that, there we go, the test passes again, that's excellent. Just saying that while we're waiting for this compile to finish, because when you're waiting for compiles to finish, they take forever. And this is only the kernel. Building world takes even longer, so I'm definitely going to have to go look at that meta modes that I've been pointed at. So thank you very much for that suggestion. All very useful. Oh, there we go. And now we can install the kernel, and we can actually, well, any decade now, I'm going to have to dig into these bugs, but that's probably not going to be a stream because that's the sort of bug that's going to take me spending a week on it, concentrating and talking about what you're doing at the same time, not to mention, drinking is difficult. So the good news is that those tests are all passing, or at least the ones that we expect to pass are passing, and then we can have, we'll let these tests finish just as a sanity check. Excellent, there we go. So 40 out of 40 tests passed. When you ask QA to report, it also includes an overview of the tests that we skipped. So we ran 40 total test cases, and we skipped 2 tests. We did not run them because if we run them, the machine is going to panic. Okay, and we can now reboot this. This box, happily, it reboots fairly quickly. One of these days I'm going to have to take a look at these lock order reversals as well. Oh, we're taking a sleepable lock after a non-sleepable lock. I think, yeah, the PF sync lock is non-sleepable, and there might be a sleepable lock in some of the code that we call, so that might be might be worthwhile looking at. It's not a huge problem, but it's worth looking at in due course. But that's not going to be today. So if I queue a test now, do people want to bet on what's going to happen? No? Yes? Maybe? Going once? Going twice? I'm kind of cheating because I know what's going to happen. And it might not be what you expect. It's not going to panic because all of the tests are going to get skipped because we didn't actually load PF yet. So if we load PF sync, which depends on PF, so this has implicitly loaded the PF module. There we go. Both PF sync and PF are loaded. Now we're actually going to test something, and it might panic. It might. It's not impossible, but I'm relatively confident this will actually just work. So we'll just let the test run. How long did that take last time? It took 93 seconds last time. And the first of the tests that uses the newly virtualized lock actually already passed. So did the second one, and now the third one is running. So, we're building confidence that this will actually work. This one got skipped, that's all good. While we're here, while we're waiting for the tests to finish anyway, we might as well, right, yes, we've still got those changes. Locally, we should revert those. And we should add only these. We don't need these, we don't need this. We definitely don't need this. Actually, while we're here, might as well go ahead and revert a couple of these changes that and yeah. Okay. And there we go. So this is essentially all that the change involved, which is that's pretty good. And the test just succeeded, so that's excellent. We'll run them again just in case, but we can commit this. Well, I'm going to commit it locally. I think I'm going to push this one for review because we might as well. Yes, thank you for being wrong, chat. It's always a pleasant surprise when things don't panic. It's very much a surprise when they don't panic, but it is a pleasant one. So we want our commit message, pf frag mutex protects fragments queue. The fragments queue is virtualized already. And there we go. That's essentially all we need. And this is, well, it could reasonably be MFC'd, but we're just not going to. And git log, what is the hash? Because we can arc-git this one to network. Yeah, git clean, because someone in chat pointed me at this last week, and this is a very useful little command. Arc-git That's the hash we want to push. Might as well go and push this one out. And there we go. There's another review pushed. I think that's been pretty good effort for today. So I'm going to give up for now. I'm going to, well, I seem to have committed to doing another stream next week, where there will be a pleasant surprise for me and where I'll explain the reasons for my celebration next week. Thank you all very much for joining us. Sorry to those of you who have just joined us as I'm, closing out the stream for today. One good remark, if it doesn't panic, how confident are you that there is a bug that you didn't find yet? I am aware that there are always bugs. There are many, many bugs in PF. There are a lot of bugs all over the kernel, and I keep tripping into a lot of them. And sometimes when you spend a lot of time, on fixing bugs, on debugging things, on looking at user bug reports, on doing small improvements, you keep seeing panic after panic after panic after panic. And it's easy to start to get this impression that this code is terrible and never works. And it's kind of unfair because I spend all of my time chasing bugs. So naturally, I do spend a lot more time seeing bugs and seeing panics and seeing things go wrong. For the vast majority of people, it just sits there and it works. I run current on my home gateway and it just sits there and it works. I run 12 stable on my mail server and it just sits there and it serves mail. It just works. It's just that I go and look for all of the cases that don't work. So naturally, I see a lot of cases that don't work. But we've done several commits today. We've added a new test. We have a small but potentially useful performance improvement. I think this has been a good day. Thank you very much for being here. Please don't tell me that you run my code in production. It just, it just scares me. It just costs me sleep quality. So don't tell me that, please. Thank you very much for being here. I'm going to go sort out dinner now because I'm getting hungry. Oh, and I should finish my beer. Trappist Rochefort number 6. Definitely not a terrible beer. Not my absolute favorite, but not a terrible beer. And that's a good note to end on.